Hello and welcome to my Pre-Algebra review series. This video covers Chapter 3, Section 8, titled Simplify a Problem. By the end of this video, you will have reviewed the three-step read, and understand, plan and solve, and look back and check process. This is a process for helping one to think through a problem, devise a method to solve it, and then look back at the work to verify the outcome. Please leave a like if you find this video to be helpful. Give your classmates a heads up too. It will more than likely help them, and certainly it will help this channel to be seen by more students. If you would like me to cover any of these topics in greater detail, please leave a comment here in the comment section below. I read them and do my best to address each as time permits. Please subscribe to my channel and ring the bell icon to be notified every time I release a new video. Thank you. Let's get into it. Objective 1. Simplify the problem. Scientists often encounter problems that are very complicated. When they work to develop a new vaccine or develop a new method to fight a disease, they usually work on a smaller or simpler pieces of the problem first. Sometimes when you work to solve a problem, it helps to solve other problems that have similar conditions. Here is a well-known problem that shows you how to use this strategy. Example 1A, real-world problem solving. So this is going to be a multi-slide example. And I think there's only one example on the set of slides, so it'll go pretty fast, I think. A snail is trying to escape from a well that is 10 feet deep. The snail can climb up 2 feet each day, but each night it slides back 1 foot. How many days will it take the snail to climb out of the well? So read and understand is the first part of this process for we're making problems simpler. Okay? And a snail needs to climb 10 feet to escape from the well. It can climb 2 feet per day, and at night it slides back 1 foot. So here's the first question that you need to ask. How far up the well will the snail's travel be after the first day and night? Well, it's going to go up after the first day and whole night. It's going to go up 2 feet. It's going to go up 2 feet. And then it's going to go down 1 foot, right? So the total is going to be 1 foot. How far up the well will the snail be after the first day and night? Next question. How far up the well will the snail be after the second day? After the second day, not including the night. After the second day, the night hasn't come yet, so we know it goes up 2. So it's at 3. It's at 1 right now to start. In the morning, and the morning of the second day, it was up 1 foot. It's going to climb up 2 feet. So it's going to go up 2. And then that's where it's going to be. It's going to up to 2 plus the 1. It's going to be equal. It's going to be 3 feet up the wall on the second day. How far up the well will the snail be after the second day and night? After the second day and night, it's going to be up 3 feet at the end of the second day, but then at the end of the second night, it's going to go -1. It's going to slide back down, so it's going to be at 2 feet. Plan and solve. This is example 1B, the second slide. At first, you might think that the snail progresses 1 foot each day, and therefore it will take 10 days for the snail to escape. Well, this answer is wrong. However, because it leaves out one important part of the problem. It says, try to solve a simpler problem. Change the problem to a simpler one based on, say, a 3-foot well, and then try a 4-foot well, and see if there's a pattern to be found here. So let's go ahead and do that. I'm going to start off. I'm going to draw a well. So I'm going to draw the well. Okay, it's not going to be very good, but we're going to draw it down here. Okay, so this is a well, and it's going to go down, okay, into the ground. Here's the ground. Okay, simple. So this right here we're going to go with 3 feet. This is 3 feet right here. And so I'm going to divide this into thirds. Okay, so this is 2 feet, 1 feet, 1 foot, and 0 feet. Okay? So the snail's down here on the bottom. Here's a little snail. Okay? So he's going to, on the first day, he's going to do what? He's going to go from 0. I'm going to do it on this side so we don't mess up the numbers. He's going to go up 1, up 2 on the first day. He'll get to this height. And then at night, he's going to slide back down to this point, to 1 foot. He's starting out here. So now he's going to go up up 2. And then you think, well, let's see, up 2. And then you think, well, he's going to slide down 1, 2. He's going to slide down 1 foot. But guess what? He has to get out of the well. And at the end of the second, with this 3 foot well, this first day he's going to go up 2 feet and down 1. And then he's going to go from 1 foot up 2 feet. And when he does, he's at 3 feet. And where does he have to be to escape the well? He can get out right there at the end of the second day. So he's going 3 feet. He can get out at the end of the second day. Let's do a 4 foot well. There's a 4 foot well. I'm going to draw it down deeper. Not a very good well, I mind you, but, and we're going to divide that in half. We're going to divide that in half. We're going to divide that in half. Do it over here, over here, over here, and it's close. And this is 1, 2, 3, 4, and here's the ground. So what's the snail going to do? On the first day, he's going to go up 2 feet and then down 1 foot. And then the second day, he's going to go up 2 feet and down 1 foot. Then on the third day, he's going to go up 2 feet. And guess what? He can escape. So he went up 1 day, 1 full day, 2 full days, and a half, a day only. Let's say it this way. Up a day to a day and then down a foot. That's the full first day. The full second day is up to 3 feet and down to 2. And the full third day without the night is up to the 4 foot mark. Okay? So let's say that's 3 days and no nights. No ending night. So that's 4 feet. He's going to do it in 3 days. 2 full days and then days and nights and a day. The 3 foot pattern was he went up for 3 feet. He went up 1 or 2 feet and down 1. That's the first whole day with night. Then he went up 2 feet and he was at 3 feet. He was done. So to go 3 feet, it took him 1 day and then 1 full night and day and then a day. So how long is it going to take him to get out of a 10 foot well? 10 foot. 5, 6, 7, 8, 9, 10, whatever, 4, 3, 2, 1. Okay, so he's going to go all the way up this. He's going to get to the 10 foot mark. And what day is he going to get there on? If he's going to 4 feet, he gets there on the second day plus a whole one. So if he's going up 10 feet, he's going to get there on the 8th day plus a whole one. Right? Is that right? Yeah, that's correct. So my thinking is right. So it's going to take him 8 whole days. He's going to go up and down, up and down, up and down, day and night, day and night, day and night for 8 full days. And then on the last, then plus 1 full day, that'll be the 9th day, he will escape on the end of the 9th day. Not including the night, at the end of the 9th day. Okay, so here's example 1C, the third slide of that problem. And now that we have a chart to fill in. Let's give it a shot. It says using the information from the simpler 3 and 4 foot well problems, describe the pattern. So here here's the 3 foot well right here, and here's the 4 foot well. We're going to describe the pattern. So what do? On the first day, see, we have a day one, a day night, one night two. So on the first day, we're up two. At the end of the first day, we're up two. Then at the end of the first night, we're 2 minus 1 equals, we're back at 1. We're starting at 1 now. On day 2, we go up 2. So it's 2 plus the 1 that we already had is equal to 3. And how deep is the well? We've escaped at the end of the second whole day. So it's one whole day night, and then a day. Let's do the 4-foot well. Same thing. Day 1, we're at 2 feet. At the end of night 1, we're at 2 minus 1 feet is equal to 1 foot. On day 2, we start at 1. We go up 2 feet. Plus we started at 1 foot. We're now at 3. We're still not out of the well. Okay. At day 2 night, we're at 3 at the beginning of it, and then we're going to subtract 1 because we're going to slide back. We are now, or he is now, or she, or whatever, is now at 2. So on day 3, what happens? You start at 2. You start at 2. That's backwards for what I've been saying, but you start at 2. You add 2 to it, and you're at 4 feet. And how deep is the well? 4 feet, 4 feet, 3 feet on the 3-foot well. So it took one whole day and night, another whole day and night, plus a whole day to go 4 feet. So it's the depth of the well minus 2 plus 1 day. So in this case, it was 4 minus 2 would be 2 full days plus a day. That's what it was. Here's a full day. And then we go up this other whole full day. And then we got the last half day, right? So it says, using the information from the simpler 3 and 4 problems to describe the problem we just did. Okay, how many days will it take the snail to escape the 10-foot well? Well, based on this, you're going to take 10. We're going to subtract 2 from it. It's going to be 10 minus 2 is equal to 8. And then we're going to add back 1 full day. So it's going to be 8 and plus 1 full day. I mean, that's the 9th day here, right? 8, that's days, and now we're at the 9th. So it's going to take 9 days. Everybody understands that? We took the depth of the well, we subtracted, we had 2 full rounds, up and down, so that meant 2. 4 minus 2 gave us the 2. And then we had to go up that final beginning of the day with no night. So it was 2 and let's say 2.5 full days. And 2.5 full days on the 4 means that we started at 10, subtract the 2 and add that half full day, so it's 9 full days. Okay, example 1D of our real world problem. Now we're going to look back and check. So what they say is you can check your answer by drawing the diagram and fill it in and see how it worked out. Did our using the smaller wells prove to be correct when we decided about how many days it would be for our larger wells, 10-day well? Okay, a 10-foot well. So we're going to start off. We're going to start on day 1. We're going to start doing this. On day 1, we start at 0 feet. Okay, and we go up 2 feet, and then we go down 1. And then on day 2, we go up 2 feet and down 1. Then we're going to go from here, we're going to go up 2 feet and down 1. From here, up 2 feet, down 1. 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 Up 2 feet, and he's out. On day 9, after the trip up, he will escape the well right there on day 9. So that proves our point. We said the same thing, that we took 10 days, it was 10 feet, we subtracted 2, got an 8, and then added the upward swing from day 9. That was our theory, and it was correct.